Welcome to the second year students, the English section program. The course, Computer Applications. The lecture starts from page 62 up to 92. This course is presented by Dr. Fايد. Chapter 3. The Central Tendency Applications. This chapter introduces the key concepts related to how commercial software works. The following topics are addressed, such as mean, median, mid-range, and mode. After finishing this lecture, students should be able to learn the Microsoft Excel skills to compute the arithmetic mean, the median, the mode, and mid-range. Also, the MATLAB skills to compute the arithmetic mean, median, mode, and mid-range. In addition to the SPSS software skills to compute the arithmetic mean, the median, the mode, and mid-range. The statistics, as far as we know, if everything were the same, then there is no need of statistics. But people heights, ages, weights, etc. do vary. In this case, there is a need to measure the extent to which scores in a dataset differ from each other. So, the measure of central tendency gives us a summary of the middle of the data. The most intuitive of these is the mean of the data, but there are other kinds that we will see shortly. The central tendency is the point at which the distribution is in balance. The mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data. The mean is equal to the sum of all the values in the data set divided by the number of values in the data set. The sample mean and the population mean are given by X bar and mu. In case of ungrouped data, the sample mean X bar is equal to 1 over small n sigma the observation xi from I equal 1 up to n. And the weighted mean x bar w is equal to sigma wi multiplied by the observation xi divided by sigma wi. The population mean mu is equal to 1 over capital N sigma observation xi from I equal to 1 up to capital N, where the observations x1, x2 up to xn are the data sets or observations. Wi is the weights, x bar the sample mean, and x bar w the weighted mean, mu is the population mean, small n the sample size, and capital N the population sign. Using Excel, the mean is defined as equal sign average the cell range from P1 up to cell Pn. Using MATLAB, the function used to calculate the arithmetic mean is called the mean of the data entry X. Application 1. For the following data set, given 10 data set, as you see in the following table, then find the mean value mathematically, the mean value using Excel, the mean value using MATLAB, and the mean value using SPSS. Solution. The mean is defined by X bar, case of sample mean, 1 over n sigma observations XI. So 1 over 10 multiplied by 1.4 plus 2.1 until the end, you will get the X bar value mathematically 3.3. The mean value using Excel, we have to input the data set in cells P1 up to K1. Then write the following formula in cell P2 equal average from the cell P1 up to K1, as you see in figure 1 and 2. The cell range from P1 up to Pn as you see in the given figure 1, from P1 up to K1, the data entry, then the average, the formula written in P2, which is equal average, round the brackets, P1 colon K1, then round the brackets. Then press enter to get the average value, which is equal to 3.0, which explained in figure 2. You will see the formula by clicking the formula tab, then click show formula. You will get the formula displayed in cell P2. The mean value using MATLAB, enter the data in the command window as follows. The variable x equal square brackets and data are separated by comma, then enclosed by square brackets. Then write the formula m equal mean, the function mean, small letters of the variable x surrounded by round brackets. See figure 3. Enter the data x. As you see, the resultant value of the data entry will be in columns 1 up to column 6. Then the remaining 4 data set will be displayed in column 7 up to column 10, as you see. Then the function mean of the variable x of the data entry x will be assigned the capital M to get the resultant value of the mean. The mean value using the SPSS software, write down the variable x in the variable view. By running the SPSS software, you will get the window as you see in figure 4, which consists of 2 windows. One is called variable view and the other is called data view. The variable view contains the name of the variable. We have to write the name of the variable, then select its type is numeric, the width, and the decimal point after 2 decimal points. Then select the measure of type scale, then switch to the data view to enter the data. Enter the data in the data view window as in figure 5. In data 5, the variable will appear, the name of the variable x. Then you have to write the data in a column under the name of the variable x, 1.42. Remember that there is the data number 3 should be 2.6 instead of 26. After finishing the data entry in data view, then click Analyze, then select Descriptive Statistics. Click Analyze from the menu, Analyze, then click Descriptive Statistics to get descriptive and figure 6. Click Analyze, then click Descriptive Statistics, then select Descriptive to get figure 7. From figure 7, we have two panes, the left pane and the right pane. The variable x will appear in the left pane. To compute the mean value, you have to move the variable x from the left pane to the right pane. By clicking the arrow, select the variable x, then click the arrow between the two panes. It will transfer the variable x from the left pane to the right pane. Then click Option. Click Option, select the mean value, then click Continue and press OK. You will get the value of the mean x within the points, and the mean value will appear in the displayed window. Descriptives. Properties of the mean. The mean includes every value in your data set as part of the calculation. The mean is the only measure of central tendency where the sum of the deviation of each value from the mean is always 0. The mean minimizes error in the prediction of any one value in your dataset, since it produces the lowest amount of error from all other values in the dataset. There is some limitations on the mean value, and the mean is not often one of the actual values that you have observed in your dataset. Despite its popularity, the mean may not be an appropriate measure of central tendency for skewed distributions and outliers. Application 2. The following table represents the yearly wages in dollars of 10 staff at a factory. we have 10 staffs with their salaries varies as you see 15,000, 18,000 until it reaches to 90,000 and 95,000. Find the mean salary of 10 staff mathematically, the mean salary using Excel, the mean salary using MATLAB. Then does the mean salary represent a better measure of central tendency in this example? If it is not, state the reason and give your suggestion. Solution. The mean is given by x bar 1 over n segment the observation xi, which 1 over 10 multiplied by 15,000 plus 18,000 and so on until it reaches to 95,000. You will get the mean value of the sample salaries $30,700. The mean salary using Excel, enter the data among the cells from P3 up to K3, then write the following formula in cell P4, average the data range between P3 and K3, which is displayed in figure 10 and figure 11. You will see the data entry start from P3, end with K3. Then write down in cell P3 equal sign average round the brackets P3 colon K3, then round the brackets. Then press enter to get the value of the average using Excel. To display the formula, click the formula bar in the formula tab, then click show formula. You will see the formula in P3, in P4. The mean salary using MATLAB, enter the data defined by salary, take the 1000 as a common value, then star square brackets 15, 18 until it reaches to 95, then square brackets. Then write down the formula, capital M equal the mean of the variable salary surrounded by 2 round brackets. See figure 12. The salary equal 1000 star the data closed by square brackets. You will get the resultant data entry from column 1 up to column 10. Then calculate the mean by using the function mean of the variable salary to get the mean value. The mean value from figure 12 and figure 11, the mean value does not reflect the typical salary of the staff, since most workers have salaries between $12,000 and $18,000. This mean is not a better measure of central tendency in this case, because the salary is being skewed by the two large salaries. Therefore, median is a better measure of central tendency in this case, which will be discussed later on. Application 3. Consider the weights or the weighted data set given in the following table. Given the observations xi and its weight wi, 40 with weight 3, 50 weights 4, 60, weights 5, and so on. Find the weighted mean mathematically, the weighted mean using Excel, the weighted mean using MATLAB. The weighted mean mathematically will be obtained by multiplying the weight by its observations, then taking the summations divided by the sum of the weights. As you see, you will get the weighted mean X bar W. The weighted mean using Excel, we have to enter the observation Xi among the cells P6 up to H6, then enter the weights Wi among the cells between P7 up to H7, then write the following formula in cell B8 by multiplying P6 by P7 by writing equal P6 star P7. Then click and drag the autofill mark until to reach to H8. Then write the following formula in cell B9. Sum of the cells between B8 up to H8 divided by the sum of cells between B7 up to H7. This can be viewed in figure 13 and figure 14. Entering the variable X between P6 up to H6, then the weights between two P7 up to H7, then multiply B6 by P7 by writing equal sign B7 star P6, then click and drag the autofill until to reach to H8. Then write in P9 sum of cells P8 up to H8 divided by sum of cells B7 up to H7 to get the weighted mean, which can be displayed, the functions displayed by selecting the formulas, then show formula. You will get the data and the formula corresponding to each cell, as you see in figure 14. With the data and the weights, then the weight multiplied by the observation X equal P6 multiplied by P7, click and drag until to reach to H8. Then the weighted mean equal sum B8 up to H8 divided by sum of P7 up to H7. The weighted mean using MATLAB. Enter the data in command window. X enclosed between square brackets, and all the data are separated by comma. Then enter the weights W closed between square brackets, and the weights are separated by comma. Then write down the following formula M to calculate the weighted mean equal sum W dot star X, since the W is an array and X is an array, then the multiplication will be denoted by dot star divided by the sum of the weights W. See figure 15. Enter the variable X, then the resultant entry data X will appear, then enter the weights W, and the resultant data entry weight W will appear. Then write down the formula M equal sum round the brackets W dot star X round the brackets slash sum of W surrounded by round the brackets. You will get the weighted mean in figure 15. In case of grouped data, the grouped data mean will be defined by X bar G, which is equal sigma Fi Mi divided by sigma Fi, where F1, F2, Fn is called the frequency distribution, Mi is the center of class, X bar G is the grouped mean, N is the sample size. Application. Consider the frequency distribution given by the following table. The class C and the frequency F. The class varies from 10 up to 15. The frequency is 5. From 15 to 20, the frequency is 4, and so on until you reach to 35 up to 40 is equal to 1. Find the grouped mean mathematically. The grouped mean using Excel. The grouped mean using MATLAB. Solution. The grouped mean calculated mathematically by computing the center of the class M as follows. The center of what? The center of the class M is equal to the lower class plus the upper class divided by 2. For each class, calculate the lower plus the upper divided by 2 to get the center of the class. After computing the center of the class, each frequency is multiplied by its center, summing the numerator, then divide the sum by summing the frequencies. You will get the grouped mean X bar G. The grouped bar, the grouped mean using Excel, enter class lower among cells B11 up to G11, enter the class upper among cells B12 up to G12, write down the following formula in cell B13 equal summing B11 plus B12, then divide the result by 2, then click and drag the autofill mark until to reach to cell G13, then enter the frequency among cells B14 up to G14, then write the formula in cell B15 by multiplying B13 by B14 started with equal sign. Then click and drag the autofill to reach cell G15. Then write the following formula in B16. Sum equal sign sum of cells B15 up to G15 divided by sum B14 up to G14 as in figure 16 and figure 17. You will see the lower class, the upper class, the center, which is calculated by equal sign B11 plus B12 divided by 2. Then click and drag until to reach to G13. Then enter the frequencies. Then calculate the value of the frequency multiplied by the center by writing equal sign B13 multiplied by B14. Then click and drag until to reach to G15. Then write the final formula to calculate the group mean. By clicking the formula bar or formula tab, then select show formula, you will get the formulas in each cell as in figure 17. The group mean using MATLAB. Enter the data in the command window as class underscore L equal. The data are surrounded between square brackets and separated by comma. Then enter by the same way class high H. Then the center is equal to class low class L plus class H divided by 2. Then enter the frequency by the variable abbreviated by frec equal square brackets the data of the frec separated by comma then enclosed by square brackets. Then write down the following formula. M is equal to sum of the array frec dot star center divided by sum of the array frec. See figure 18. Class L, the output of the data entry class L, then class H, and the output of the data entry class H. Then calculate the center by adding class L plus class H, then divide the result value by 2 to get the center. Then enter frec, the frequency. Then M, calculate M is equal to sum of frec dot star center divided by the sum of the frec to calculate the group mean. The median. The median is a popular measure of central tendency. It is the value in the middle of the dataset. It is the 50th percentile of a distribution. The median is preferable than the mean in case of skewed distributions and large outliers. To find the median of a number of values, arrange the data in ascending or descending order. In case of odd number of data points, the order of median is given by MR equal to the sample size n plus 1 divided by 2. Then the median is the value which corresponds to the order MR. In case of even number of data points, the order of median is obtained as follows. Compute the order of the two middle points. The order of the two middle points, M1 at n over 2, and the second order of the middle point at n over 2 plus 1. Then the median is the sum of values corresponding to the order of M1 and M2 divided by 2. To find the median using Excel, enter the data among cells, say for example B1 up to Bn, then write down the following formula. In any cell equal median from the cell range P1 up to Pn. To find the median using MATLAB, write down the following formula. Median of X. Application 5. The following table represents the monthly wages in dollars of 10 employees at a company. Given 10 employees from 1 up to 10 with their salaries as given in the table, then find the median of salary for 10 employees mathematically, the median of salary using Excel, the median of salary using MATLAB, the median of salary using SPSS. Give your comment about the median value. Then, does the median value represent a better measure of central tendency in this example? If it is not, state the reason and give your suggestion. Solution. The median of salary for 10 employees mathematically. The median is given by arranging the salary in ascending order. You will get the following table. Then compute the order of the two middle points. Then the number of employees is equal to 10, which is an even number. So the order of the two middle points, M1 at 10 over 2, which corresponds to employee number 5, and the order of the second middle is at 10 over 2 plus 1, which is number 6. Then the median is the sum of the values corresponding to the order of M1 and M2 divided by 2, which is equal 1500 plus 1600 divided by 2 to equal $1,550. The median of salary using Excel, we have to enter the salary among cells B17 up to K17, then write the following formula in B18, median from the cell range B17 up to K17 as given in figure 19 and 20. Given the data salary, then the median from B17 up to K17, you will get the median value. To display the formula, select the formula tab, then click the show formula to see the formula in figure 20. The median of salary using MATLAB, enter the salary as given, take 100 as a common value, star square brackets the data, then enclosed by square brackets, then write the median value equal median of salary as in given in figure 21. Salary, data entry, then the median of salary to get the value of the median. The median of salary using SPSS by the same way as we did in the main. Write down the variable name salary in the variable view by running the SPSS version. You will get two windows. One is called variable view and the other is called data view. And then in case of activate the variable view, then write the name of the variable salary, select as type number, numeric, and it's a measure of type scale. Then click the data view, then enter the data under the in a column array under the variable name salary until to end. Then click analyze. Click analyze. Select descriptive statistics, then click frequencies. Then select the variable salary from the left pane and click the arrow between the two panes to transfer the salary from the left pane to the right pane. Then click statistics. Click statistics, then select the median, then click continue and press OK to get the median value using the SPSS as we see in figure 27. The comment: this median value reflects the typical salary of the employee, since most workers have salaries between $1,200 and $1,800. This median is a better measure of central tendency in this case because the salary is being skewed by the two large salaries. Therefore, median is a better measure of the central tendency in this case. Thank you very much, and see you on the coming Saturday.